Long before anyone measured an angle, someone simply noticed a shape. A triangle in a mountain silhouette, a circle in the sun. Geometry didn't start as a subject, it started as noticing. Let's slow down and notice again, together. Every triangle, no matter how you stretch or squash it, holds onto one quiet promise. Its three angles will always add up to exactly 180 degrees. Always. This isn't just a rule in a textbook, it's a law of nature. That single, unshakable fact is why triangles are the backbone of our world. You see them in the trusses of bridges, the frames of roofs, and the skeletons of radio towers. Why? Because they distribute weight evenly across their structure. While a square can be pushed into a diamond, a triangle doesn't bend or warp under pressure. It simply holds its form, steady and strong. A circle holds its own quiet, perfect secret. Take any circle in the universe, a bicycle wheel, the top of a coffee mug, or the orbit of a planet. If you measure the distance around its edge, its circumference, and then divide that by the distance straight across its middle, the diameter, you get the same number every single time. Approximately 3.14. We call it pi. What's truly amazing is that pi is an irrational number. Its digits go on forever without repeating. It's not an invented number, it's an inherent property of roundness, a constant woven into the fabric of space itself. Here's a quieter kind of magic, a relationship so fundamental it was used long before the Greeks gave it a name. In any right-angled triangle, if you create squares on the two shorter sides, their combined area will perfectly equal the area of a square on the longest side. A squared plus b squared equals c squared. While we credit Pythagoras, ancient Babylonians used this principle over 1,000 years earlier to draw precise property lines. Today, it's just as practical. It's how a carpenter ensures a corner is perfectly square, how your phone screen size is measured corner to corner, and how GPS calculates the straight line distance between 2 points. Once you start looking, geometry becomes impossible to unsee. The world becomes a gallery of intentional shapes. Think of the hexagon. Bees use it for honeycomb because it's the most efficient shape for tiling a surface, using the least wax to hold the most honey. We've copied that natural genius in floor tiles and in the mirrors of giant telescopes. You see rectangles in every window and door, creating stable frames, and those circular manhole covers, they're round for a simple, brilliant reason. A circle is the only shape that can't fall through its own opening. None of this is a coincidence. Shapes carry quiet properties, doing their job whether we notice or not. A triangle that never buckles, a circle that always keeps its perfect ratio, a hidden theorem in every ladder leaning against a wall. That's the heart of geometry. It's not a set of abstract rules to memorize for a test. It's a language for understanding the inherent logic of the world, the quiet, elegant shape of things already all around you. Thanks for noticing with me.